So today I'll be explaining the chemistry quiz for week 9, and I'm just going to explain it. So, which of the following are used to test the presence of ammonia gas? Ammonia is NH3 and it is basic, meaning that if we test it using red litmus paper, we get blue. Okay, and it also has a pungent smell, like a really strong smell, and you can test it using a rod dipped in HCl, and then you get white gas. Okay, so let's check the options. So blue litmus paper, that's wrong, because blue litmus paper is used to test acids. Glowing splint, wrong, because we use that for testing O2. Rod in HCl, that's correct. Red litmus paper, that's correct, because as we said, ammonia is basic. And a lighted splint, that's wrong, it's for H2. So these two. Now here, when what is mixed with a solution that contains calcium ions, no precipitate forms. So from all the tables that we memorized for last week, what do you remember about Ca? Ca, we can test it using the flame test, and then we get brick red. Or we can test it when we add NaOH, we get a white precipitate that does not dissolve in excess, and an NH3, no precipitate forms. So out of all of this information, which one lines up with the information that they gave us? This one. So NH3 is the answer. NH3. Okay, so here a few drops of NaOH are added to solution Y. A pungent smelling gas. Pungent smelling. So far, from the tables that we memorized so far, we know that two stuff produce a pungent smell. NH3 and NO3 2- when you test it. Hi, my bad. So again, when we're testing NaOH and solution Y, we get a pungent gas, pungent smelling gas. So solution Y can be two stuff. It can either be NO3 2- or NH4. But the main difference between NO3- and NH4, they're pretty much the same thing. You just heat you heat it, and for both of them you heat it and you add NaOH. But in NO3 you add aluminium powder, which is a catalyst. Powder, which is a catalyst. But then at the end, in both of these, you get NH3, which is the pungent smelling gas. So here they didn't say they added aluminium powder. So the answer is not NO3, it's NH4. Okay? Okay, and then here, an electrolyte is a substance that dissolves in water to give solutions containing ions. Okay, you have to know this, you have to memorize it. An electrolyte, it can either be strong or weak. Yeah, because they're gonna ask you that, I think, in the end of the quiz. A strong electrolyte that gives... Second time this happened. Okay. An electrolyte, it can either be strong or weak. Strong electrolyte like HCl, weak water. H2O. Okay, those are examples. Strong gives like many ions, weak doesn't give a lot of ions. Okay, so here electrolytes. Here, yeah, this is the thing I was talking about. There's only like one formula you need to memorize. Kw, which is always 10 to the power of negative 14, is equal to the concentration of OH minus times the concentration of H plus. Okay, and the temperature has to always be 25 degrees Celsius. So here Kw is 10 to the power of negative 14, and when the concentration of OH minus is equal to the concentration of H plus, it's always 1.0 times 10 to the power of negative 7, because 10 to the power of negative 7 times 10 to the power of negative 7 is equal to 10 to the power of negative 14. It's like you're doing 10 to the power of negative x, 10 to the power of x, times 10 to the power of x equal to 10 to the power of negative 14. Then you solve, you get 10 to the power of negative 7. Okay? And then because they want it in scientific notation really all the time, so you just write 1.0. Okay? And when is OH and H, when are OH and H equal? In H2O, in water. Okay, because look, there's 2H and only one O, so it dissociates to give OH minus and H plus. Okay, so here negative 7, 1 to 14. Okay, and then here, okay, let's look at the equation first. We can see that the heat is in the reactant, so it's endothermic because it takes in heat, it absorbs heat, and yeah, okay, that's it. Okay, so when we increase the temperature, if we're gonna follow LTP's theorem principle, so if my imposed change is to increase the temperature, it will, if we increase the temperature of the system, it will go, again. LCP's theorem's principle says that whenever we make an imposed change, equilibrium partially counteracts it. So if I increase the temperature, equilibrium will decrease the temperature and go to the endothermic side, which is to the right. Okay, so if it goes to the right, it takes in heat, it absorbs heat, and the value of Kw will increase. Okay, because Kw is equal to H and OH. So if we're going to H and OH, its concentration is going to increase, right? If we're going to it, but if we're going away from it, then the value of it will decrease. Okay. So here absorb and increase. OH and H are always present in aqueous solutions, because the equation really says Kw is equal to concentration of OH minus times concentration of H plus. So we always have OH and H in really every single aqueous solution. Okay. Oh, this one's in the notes paper, you have to memorize it. Okay, so decolorizes is sulfur dioxide, because SO3 2 minus, when you add an acid, it gives SO2, which is a choking smelling gas that decolorizes KMNO4, so it's sulfur dioxide because SO2. Okay, and then terms lime water milky, CO2, pungent smelling gas, nitrate, ammonia, ammonia, colorless odorless gas, pop sound, hydrogen, glowing splint, oxygen. Okay, and bleach is litmus paper, chlorine. Okay, you have to memorize those. Okay, here you guys have to focus. We already said that Kw, which is always 10 to the power of negative 14, is equal to the concentration of OH minus times the concentration of H plus. So here they give us that H, concentration of H, is equal to, in KOH, it's equal to 0.06 molarity. That's the thing for concentration. So here, how many H's do we have? We have 1. So it's going to be 1 times 0.06. So we're going to get 0.06 molarity of OH. No, wait, H. Because again, there's H here. So that's H. Here they want H. So we literally just got it. So, oh, my bad. Guys, silly mistakes. I'm so sorry. Look here, there's OH. Don't ignore the OH, it's here. It's OH. I just found the concentration of OH. There's only one OH. So, the concentration of OH is equal to 1 times 0.06. It's gonna be 0.06. So that's the concentration of OH. And I was wondering why it was so simple. Like, I didn't need to do anything. Because there's something wrong. Sorry. Look. Here, whenever they give us anything, like for example, if they give us HCl and they said no, it's a concentration of 0.1, then we're gonna look for how many, like there's either gonna be H or OH or both. Here we have only one H, so we're gonna do 1 times, that's a 1 times the concentration that they gave us, which is 0.1. So 1 times 0.1, that's going to be the concentration for H and HCl. But here, they gave us OH minus, I just erased it, so I'm just going to rewrite it, 0.06. Here, they gave us KOH, it has only one OH, and they said, the concentration of KOH aslan is 0.06. So, we're going to do 1 times 0.06 because we only have one OH, and then we're gonna get the concentration of OH. Here we got it. We're gonna just put it in. We don't need to put it in scientific notation at the end. So here we have the concentration of OH. Now I need to find the concentration of H. How? Using this formula. 10 to the power of negative 14 is equal to 0.06 times 10 to the power of times X or times H. We're gonna put that to the other side. Let me just get my calculator. So you're gonna do 10 to the power of negative 14 over, let me just erase all this, over 0.06. So 10 to the power of negative 14 over 0.06. That's a big number. Okay, you get 1.7 times 10 to the power of negative 13. I rounded it because it's 1.666666 times 10 to the power of negative 13. Okay, but here they said two significant figures, so I rounded it. Yeah, so we get again 1.7 times 10 to the power of negative 13 when you do it on the calculator. Okay, it's really easy. You just moved one thing to the other side. So H plus is equal to 1.7 times 10 to the power of negative 13. Okay, so yeah, you should have known this by last week. Lithium is crimson red, sodium is yellow, potassium is lilac or violet. White precipitate, okay. Again, calcium ions, Ca2+. What do I know about calcium? When you test it using the flame test, you get a brick red. When you test it using NaOH, you get a white precipitate that doesn't dissolve in excess. And when you test it using NH3, you get no precipitate. Here they said white precipitate. Which one of these have a white precipitate? NaOH. So NaOH. When you add NaOH, okay? Okay, white precipitate. Okay, when you see white precipitate alone without anything else, and here it says NaOH, but that's not what we're testing. We're adding that to the thing we're testing. So whenever I see white precipitate, I remember ZAC, Z-A-C, Z-N-A-L-C-A. And you just need to memorize it in order, because, wait, Z-A-C, tick, 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 X, X, no precipitates. NaOH, and then NH3. Just add a line in the middle, Z-N-A-L-C-A. Okay, so here, this whole thing is all white precipitate. They all give off white precipitate except here, because obviously it says no precipitate. And the one that has a gelatinous precipitate is Al, gelatinous. Okay, so let's see the given. It is soluble in excess NaOH. By the way, tick يعني it dissolves in excess, يعني soluble in excess. So here they said soluble in excess. The only thing that isn't soluble in excess NaOH is Ca, so we're just gonna cross that out. Anything else? No, they only said that. So it's either Zn or Al. Okay, so let's check which one is in the options. Al. So that's the correct answer, hopefully. Okay, so here we add a few drops of NaOH are added to test tube containing AlNO3. A white precipitate forms. Precipitates are solid, by the way. Okay, so when we have to finish the equation. We have to balance it, by the way, too. Okay, so how do we get the precipitate? We do Al 3 plus and OH minus. Then we cross multiply. We did this last year, if you can remember. Al and then OH 3. Okay, that's the thing that you get. That's the precipitate, sorry, and it's solid. So Al and then OH, and then you add the 3, and then it's solid. And we need to balance, because look here, there's 3 OH and here there's only 1, so let's make it 3. Now it's balanced. Now we have to name the precipitate. We know that Al is aluminium, and it's to the power of 3, so it's power of 3. I'm so sorry, it's Al3 plus, so aluminum, then 2 high, 1, 2, 3, because look, there's a 3 on the top. Okay, and then hydroxide. OH means hydroxide, so hydroxide. Next. Okay, upon adding a few drops of NaOH to a solution that contains Fe2+. Fe2+, when you add NaOH here, you get a green, that's not how you spell green, green precipitate that does not dissolve in excess. And look here, you have to memorize this. When it's exposed to air, it turns brown. So here, green precipitate, exposed to air, turns brown. Upon adding a few drops of NaOH in Fe3+. Fe3+, when you add NaOH, you get a brown precipitate. Okay, this again. When we cross multiply Fe3+ and OH minus, you get FeOH3, solid. Okay, so FeOH3, that is solid. And again here, Fe means iron, and it has it's 3+, so I. If you didn't know that, it's a Roman number for 3, by the way. And then OH, hydroxide. Okay, then here a few drops of NaOH, so NaOH plus solution A to give a pale blue precipitate that does not dissolve in excess of NaOH. That's Cu. 2 plus, I think, right? It's Cu. Yeah. Okay, then here, again, I'm gonna cross multiply. Cu2 plus OH minus. You get CuOH2. That's solid. Okay, so Cu OH 2, that is solid. And oh, I forgot to balance the other one too. Look, there's 2 here. You have to balance it. The other question, I also forgot to balance it. I'm so sorry. Yeah, look here, there's 3. I didn't write 3 here. Okay. Back to this question. Cu means copper, so copper hydroxide. And copper is 2 plus, so I. Then close the bracket. Okay, upon adding a few drops of NH3 to a solution that contains Cu ions, a deep blue precipitate forms that dissolves in... Oh, no, my bad, wait. Pale blue that dissolves in excess to give deep blue solution. Okay. Next, Cl, Br, and I. Okay, so Cl, Br, I. Okay, so I is yellow, C is white, B is creamy. Okay, so white, creamy, right? Let me just double check. Okay. And then here, oh yeah. Oh no, wait, what? Yeah, Ba and SO4 give off a white precipitate. Give off. Okay. And then a few drops of NaOH are added to a solution that contains Zn. Remember Zach? Yes. No. Precipitate. Then here they added NaOH. We're just gonna focus on this first row. It's a white precipitate that dissolves in excess, because look, there's a tick, dissolves in excess in NaOH and does not dissolve in excess of NH3. So again, white precipitate, insoluble, solid. Okay. No, wait. My bad. It's soluble in both. It's Z, tick X, no. ZA, C. And by the way, Pb acts the same as aluminium. So it's gonna give off the same results. Okay? So it gives off a white it makes a white precipitate that soluble in NaOH and insoluble in NH3. Insoluble. Does not dissolve in excess. So white precipitate, insoluble and soluble. Okay? Then here, again, a strong, no need for capitals, strong electrolyte, when added to water, dissolves and exclusively gives ions. A weak electrolyte, dissolves and dissociates to ions. Okay, Bismillah. Okay, I hope you guys understood. Good luck on your AMS and periodics for next week. Bye bye.